And let's begin with the monolith. So what is the monolith architecture? So first, monolith architecture is the original architecture, the father of all fathers, the ancestor of all the other architectures we have today. In fact, monolith is not just an ancestor. There are still today a lot of monolith applications, and that's not necessarily a bad thing. Some scenarios are best suited for monolith architecture, and there is no reason whatsoever not to use it in these scenarios. With monolith architecture, all the software components are executed in a single process. That means there is no distribution of any kind. All the components share the same threads, memory, compute power. It's basically a huge chunk of code running happily alone, minding its own business. Now, naturally, when the whole application runs in a single process, there is a very strong coupling between all the classes. The code pieces are tied to each other, and there is nothing that separates them from each other. No network, no standard API, nothing. Another common attribute of monolith architecture is that it's usually implemented as a silo. What this means is that the monolith application is a standalone app that cannot and would not share anything with other apps. These applications does not expose anything that might help other apps, whether with data or functionality. There is no external API, no listeners of any kind, nothing that says, I know I live in an ecosystem and I would love to help the other apps in this ecosystem. No, the monolith app lives in a world of its own and keeps its data and functionality close to its chest. Nothing can go out. So let's take a look at a typical monolith application. Let's talk about an HR app. As we said, a monolith HR app is actually a single process. This process hosts all the components of the application. Note how all the components in the diagram are enclosed within this process, and so make this application a real monolith without any kind of distribution. Now, in fact, monolith applications are not really comprised of one and only one process. Quite often, they have a database which usually is in another process, unless using an in-memory database such as SQLite. And that's true mainly for web apps, the user interface is often in a different process. In web apps, the user interface is usually a web browser, which is a separate process installed on a separate machine. But even when we have separate processes for database or user interface, the application is still called monolith, since the core of the application, where the real work is done, is in fact a monolith. Now, what happens when we have another app beside our HR app? For example, say we have a purchasing app in the organization, which in this case is also a monolith. Those two apps are running happily along, not interfering with each other and minding their own business. But then a new requirement is received, and suddenly they have to communicate with each other. It can be that the HR system needs to know which orders were made by an employee, or the purchasing system should know who is the boss of the employee placing an order. Whatever the case is, they need to be able to share data between them. Well, unfortunately, this is not possible with monolith application. Monolith applications, as we said earlier, are often silos and do not expose ways to share data and functionality. So making the two apps communicating with each other is a cumbersome, frustrating experience. It can be done, but it's not easy. Now, we focused a little bit about the problems of the monolith architecture, and later on we'll talk a lot about them. But actually, there are also advantages in the monolith architecture. Let's see two of them. The first, it is much easier to design monolith. Think about it. With monolith application, there is no network, no messaging mechanisms, no queues, no cross-process debugging. It's much simpler. And simpler is not always worse. In addition, monolith applications, if developed correctly, are quite performant. Again, no network hops, no serialization and deserialization layers, all calls are in process. Monolith apps can be blazingly fast, much more than distributed systems. So that was it about the monolith architecture. And now let's look at the second architecture that predated microservices.